This video covers Chapter 1, Section 3, data structures, research methods, and statistics. Data structure 1 talks about descriptive research, which involves measuring one or more separate entities for each individual with the intent of simply describing the individual variables. For example, here are students, and we named them A through H. And let's look at student A. Weekly number of fast food meals was 0. Number of hours they slept each day was 9. Number of hours they studied each day was 3. We measured these same variables for all the different people. That's data structure 1. Let's look at the correlational method. This is data structure 2. It's one group of participants. Measurement of 2 variables for each participant. The goal is to describe the magnitude of the relationship between 2 variables. Patterns in the data can reveal relationships. This is a non-experimental method of study. For example, here's the students again. We named them A through H. Student A spends 4 hours on Facebook time, and they have a GPA of 2.4. So if we have both of these readings for each student, we can plot this on a graph. Okay, this is a correlation, and we can look and see if there's a correlation. Is it positive? Is it negative? We're going to talk more about correlations soon. So here's another example of correlation. It can demonstrate the existence of a relationship, but it does not provide for an explanation of that relationship. More importantly, it does not demonstrate cause and effect between 2 variables. For example, we know that smoking and lung cancer are related to each other, but we can't say one causes the other because we can't do a true experiment. We can't just say, okay, you 10 people are going to be smoking for the next 10 years. You 10 people are not going to be smoking, and let's see what happens. You can't do that. It's unethical. So when you do correlational methods, you're just a lot of times looking what already exists out in nature. Well, there already exist smokers, there already exist non-smokers, and we're looking at the relationship but we can't say one causes the other. All right, data structure 3 is comparing 2 or more groups of scores. One variable defines the groups, so you're either like group 1 or group 2, and then scores are measured on a second variable. Both experimental and non-experimental studies use this structure. So here's an example. Maybe you have one variable, what type of video games do you play? Violent video games or non-violent video games? And then I want you to take this little test that measures your aggressive behavior. And these are the scores that people got based on if they played violent video games or non-violent video games. So that's 2 variables. The experimental method, one variable is manipulated and one is observed and measured. The differences from one participant to another are known as individual differences. So an experiment features control, manipulation, and random assignment. The goal of an experimental relationship is to demonstrate a cause and effect relationship. Okay, manipulation. This is what the level of this variable is determined by the experimenter. For example, if I wanted to look at how babies respond being in a blue room or a red room, do they cry more? That's one variable. I'm manipulating it. I'm choosing, do I want certain people in the blue room, certain people in the red room, and I would choose who goes in what room. Control. I can rule out other instances. For example, I can control the age, the gender, motivation, personality of the people I pick for my study. So that, for example, I could put one 8-month-old baby in one blue room and an 8-month-old baby in a red room. I could put a 9-month-old in a blue and a 9-month-old in red, kind of matching variables. I'm controlling for outside influences. Maybe I also, when I run a study, look at environmental variables. maybe the time of day, the weather, the lighting, and make sure it's all the same for both groups. So here's an example. Independent variable is labeled as IV, dependent variable as DV. So independent variables are deliberately manipulated by the researcher. The independent variable is different for each group, and you must specify all parts of the individual independent variable. The dependent variable is always an output. It's usually a score of some kind. And the dependent variable is the same for everyone in the study. All right, so now let's look at an example and see if we can figure out what the independent variables are and the dependent variables are. So here's an example. Red candy versus purple candy. I want to give these to different students, and I want to measure the IQ of everybody after they've eaten the candy. What would the independent variable be here? Well, the independent variable, remember, is different for each group, so it would be the color of candy, either red or purple, the color. What would the dependent variable be here? Well, it's what I'm measuring. And remember, the dependent variable is what I measure for every single person in the study. In this case, an IQ score. Okay? And I realized that example is crazy out there, but I was hoping it might help you remember. Here's another example. Participants are given a new medication or they're given a placebo, which really doesn't have any medicine in it. It's like a sugar pill. What's the independent variable for this study? Well, medication would be the wrong answer because only half the people in the study are given the medication. Some are given the placebo. You have to include both parts. So the independent variable here is the medication and the placebo. These are the two groups. Let's talk about a control. Sometimes you have a control condition. This is where individuals do not receive the experimental treatment, like the placebo in the previous group. They either receive no treatment or they receive a neutral placebo treatment. Either way, they're control. Its purpose is to provide a baseline for comparison with the experimental condition. Example, just like we talked about, providing one group with medication, another with the placebo. The placebo group is the control condition. So let's look at an example of a non-experimental study. Okay, half the people in the study are boys, half the people are girls. So where this study is using gender as a variable, the variable can't be manipulated because you can't just say you 10 people are going to be girls and you 10 people are boys. So it's not a true experiment. So it's non-experimental. Okay, and then we're going to give them verbal test scores. And that's going to be the dependent variable will be the verbal test scores. And again, the independent variable is going to be the girls versus the boys. So gender is used to create groups. So the independent variable is gender. Independent variable is a grouping variable. Dependent variable is the verbal test score. The dependent variable is a score for every single person in the study. Okay, let's look at another non-experimental example. This time, we're going to use time as the independent variable. So it's the same group of students, but we're going to give them a depression test, and we're going to get depression scores before they start therapy and after they start therapy. So the participant variable is actually called time. It's used to create the groups. So in this case, it's before therapy and after therapy. So time is the independent variable. It's the grouping variable. The dependent variable here is the depression score. The dependent variable, again, is the score for everyone. Let's talk about a quasi-independent variable. This is a non-traditional study. It's used to create the different groups. A lot of times it's called a quasi-experimental variable. A true experiment actually has random assignment. And again, like we talked about, it's not always possible to randomly assign people to groups. You can't randomly assign people to smoke or not smoke. You can't randomly assign people, hey, you're going to be all girls, you're going to be all boys. It doesn't always work. So a lot of times we use quasi-independent variables. So again, the smoking. In this case, the independent variable would be either smoker or non-smoker. Let's look at quasi-experimental versus non-experimental. Quasi-experimental research is missing some of the strict control, some of the manipulation, and quasi-experimental has no random assignment. Here's an example, testing effects of two teaching methods. Well, you can't demonstrate cause and effect. It has an independent variable and it has a dependent variable. A non-experimental research has no manipulation, no control, no random assignment. Non-experimental research has no independent variable and no dependent variable. Okay, so quasi-experimental, you still have an independent variable, you still have a dependent variable. Non-experimental, there is no independent variable, no dependent variable. Observational research can take place in natural settings. For example, are you observing, looking for signs of ADHD? That's non-experimental research. Extraneous variables, when we talk about studies, these are variables not included in research, but they might influence the relationships observed. Okay, now let's talk about your learning check. Again, here's some more examples. Pause the video and do each one, and then turn it back on to see the answers.